Welcome. My name is Cole Hake, and this is my project 1.1, Kirchhoff's voltage law. This project includes 3 circuits, one with 3 fixed resistors, one with a power diode, a fixed resistor, and a 5mm LED, and the third circuit includes 3 even fixed resistors and 1 red LED. The purpose of this project is to further understand Kirchhoff's voltage law and how it controls the voltage differences on an electrical circuit. And in this first circuit, the 3 fixed resistors include one 470 ohm resistor seen here, one 1K ohm resistor seen here, and one 2.2K ohm resistor seen here. We know that Kirchhoff's voltage law is present in all electrical circuits, so we will know that the power coming out of this battery source will come through here and through this power diode, which takes about 0.7 to 0.9 volts, which means there is 8.1 volts actively in this circuit. And with our DMMs, we can find out the voltage drop of this first resistor, which is 2.2 volts, this 470 ohm resistor, which is 1.046 volts, and the voltage drop of our 2.2 kilo ohm resistor is 4.88. And when we add them all together, we can confirm that that adds up to 8.1 volts, which confirms Kirchhoff's voltage law being present in this circuit. Now, this is our second circuit, which again draws power from a 9-volt power supply, which is around 8.1 volts when you remove this diode, which means that around 8.1 volts will flow through this circuit, up through the diode, through this 470 ohm resistor, through this LED, powering it, and then back through this wire into the power bar. Once again, we can confirm that Kirchhoff's voltage law is active in this circuit by testing with DMMs each of the resistance of each component to ensure that it adds up to 8.1. So if we look at the diode, that has a voltage drop of 0.7 volts. Then we go over to our 470 ohm resistor, which will take around 4.56 volts, and then over to our blue LED, which absorbs 2.8 volts, and totaling those things together, we get a total of 8.1 volts, confirming Kirchhoff's voltage law. This is the third circuit, and this circuit includes our 9-volt power supply, a red 5mm LED, and 3 1 kilo ohm resistors. So our power will flow out through here into the power bar, up through this wire, turning on the LED, and going through the resistors to travel back into our negative. Next, to check for Kirchhoff's voltage law, we can measure with the DMM how much voltage drops at each component. So, starting in here, again, we have 8.1 volts. Then, once we go through the red LED, around 1.8 volts drops. And since all 3 of these are the same, each will drop around 2 to 2.1 volts, confirming Kirchhoff's voltage law. Overall, we saw that each circuit confirmed that the total voltage difference was equal to 0, which confirmed the presence of Kirchhoff's voltage law. Thank you, and I hope you learned something new.